Hey guys, welcome to the Tech Granth. Today we are going to continue the data structure for beginners, and today's data structure is queue. Do like and share the video, subscribe to the channel to get further updates. So in today's tutorial we'll learn about the basics of queues. We'll go through the operation that queue support, and we'll also go through the implementation, but will not do hands-on on the implementation. I'll split it into two videos like I did for the stack. So if you have not watched the stack video, the link is there in the description. You can check out the content on stack and also how I implemented it using arrays. So I'll follow the same pattern for queues. In this video I'll just go through the implementation techniques and the common questions, and in my upcoming videos I'll go through the hands-on implementation. So what is a queue? Queue is also a linear data structure which is used for storing data. It works on a first in first out kind of model where whatever input that is received in the queue first, so that part is processed first, and so on. So if you see, suppose these are this is a queue of integer, so I have some set of integer which is coming into my queue. So whatever integer came first, so first processing will happen on the integer which came first. So it is like first in first out, so whatever comes first it will be processed first. This is exact opposite of stack, where it used to work on last in first out, where last integer or last element that went into stack, that was processed first. So to relate it in a real time environment, you can think of it as a line where whoever comes first in the line, so his work is done first, and then the next person in line, he will be eligible to get his work done, and so on. So that is how a queue works. And queue is also a data structure which is unlike array, where you have to define memory in the at first hand, where basically when you declare your array you have to give the memory size, so you don't have to do it with queue. The memory is allocated to the queue as and when elements are added to the queue, and that is how the queue size also increases. So there is no upper bound to queue memory. It is only restricted by the memory of your JVM or the memory that has been allocated to the process. So queue also has the similar kind of operation like any other data structure. You add element to the queue, you remove element from the queue, and you check what is the top element of the queue. So the naming convention for those are, when you add an element into a queue, it is called enqueue. When you remove an element from a queue, it is called dequeue. And the top element, or the first element that will be eligible for dequeue from a queue, is called front. So if you see this example of the queue, this is a queue again of an integer. So this side, the rightmost side is the front, and leftmost side is rear. So unlike stack, it has two gates. One means from one side the integer or any element enters, and there is another gate from where it exits. So if you compare it against stack, so stack had only one entry point or one gateway from where element used to enter and go out, whereas in case of queue we have two gateways. The element which enters from a gate, it does not exit from the same gate. So if you see this 5, it entered from this rear end, and it will be dequeued, or it will go out from this front end. So in this queue of integer, first element that was added was 5, then 3, 7, 4, and 2. And when you have to dequeue, or when the element is eligible for processing, it will be removed from this end. So it will be added from here and it will be removed from this end. So first 5 will be removed, after 5 3 will be removed, and then 7, then 4, and then 2, so on. That is how the first in first out will be processed, because first 5 entered first, so it will leave the queue first. Then 3 entered, so 3 will leave queue next. So that is how it implements first in and first out. And the operation associated are enqueue. So when you inserted 5 into this queue, you said you enqueued the integer 5 into this queue of integer. When you pick up 5 from this front end and remove from the queue for processing, that operation is called dequeue operation. And if you have to, like in stack we used to peek the topmost element, so if here you have to peek, or the term is front, if you have to check the front element of the queue, you say get front or is front kind of operation. So these are the common operation which is supported for queue. So hope it is very clear. It's very simple data structure, it is linear data structure, and it will be helpful in tons of scenarios, whether you are working with other data structure like trees, or in traversal of trees, and if you have to implement a lot of other scenarios where it has to be in a first come first serve basis, so there you will go with the queue. There are a lot of other other types of queues basically, which we will deal later, like priority queue and all, which is an advancement, or that is like customized kind of queue which serves different purpose. But yes, it is also a very helpful data structure. Now if we come to the implementation part of the queue, like stack, it can be implemented using an array. We'll do the implementation of queue using array in my next video, and if time permits, I'll make a video on implementing queues using stack as well. So basically you can use these two data structures to create queue data structure. You can also use linked list, like in case of stack also we can use linked list to create stack data structure. So similarly, linked list can also be used to create queue data structure. And yeah, we'll go with the hands-on in my next video for this. And the common kind of question which is asked for queues are or these are not the question, basically the common scenario where you are going to use queue will be when you are doing a multi-threading kind of thing, and you you have multiple threads and a limited resource, so you will assign all your tasks as part of the queue. When you talk about queue, you can relate it to job scheduling or connection pooling kind of thing, or making asynchronous calls also. So in distributed system where you have lot of calls coming in and you have asynchronous kind of systems, so there you use queue. Basically you just put your call in the queue and you forget about it, and as and when that call reaches the front of the queue, it will be dequeued and it will be used for processing. A lot of orchestrator that is present in today's world, they uses this queue mechanism and this queue data structure. So these are few of the implementation. And even for for collecting some statistics and all, when you have a batch kind of system where you have to run some process and in between you want to collect some statistics of the batch, so you can use queue. And I will tell more about it when we will discuss priority queue later, where you can assign a lower priority jobs and a higher priority jobs kind of thing. But yeah, that is it for now for queue data structure. If you have any question or any confusion, do comment on the video and let me know. I will try to help you. Next I'll be going with trees data structure, but before going to trees I will come up with a video for this hands-on implementation of queue using arrays. So watch out for that video. Subscribe to the channel. See you in the next video. Bye.